Hello friends, Namaste and Jai Hind. Welcome to my show Engineering and Technology Made Simple. This is another lecture series I'm starting on subject of artificial intelligence. Artificial intelligence is basically not a single subject but collection of many subjects like signal processing, linear algebra, optimization theory, machine learning, deep learning, and various artificial intelligence framework. So this will form a very long series of lecture, and I hope I can cover multiple aspects of this subject in this lecture series. The objective of this lecture series is to make artificial intelligence subjects simple to understand, and one can also deploy in real life application. In order to achieve this, I have segregated various topics into the following one. The first one is understanding the concept of artificial intelligence with physical interpretation. The second topic is mathematical foundation, which is required to implement various algorithms. The third one is various subjects associated with artificial intelligence and algorithms involved in that. The fourth one is deep learning models and mathematical foundation. The fifth one is various frameworks used to implement artificial intelligence models. And the final one is implementation of these models on various embedded platforms. So let's begin with the first lecture of artificial intelligence. Artificial intelligence is basically a biologically inspired concept from human intelligence. Now, what is a human intelligence? Basically, it is a decision-making capability of human, which can either classify the object or predict the future moment. This intelligence, whenever it is mimicked inside the machines, which are nothing but computers, in the form of software algorithm, it's called artificial intelligence. Now, how can one make computers to take decision? The underneath model is nothing but a mathematical model which has two parameters, variables as x and parameters as w. So it will form a function of x and w and will generate the output y, where y is a discrete output in case of classification or continuous output in case of regression. Consider a simple model as shown below. So model is considered here as a simple straight line equation y is equal to mx plus c, and that can be transformed into a form of w as y is equal to w0 plus w1x. So where w0 is mapped to c while w1 is mapped to m. In this model, there are only two parameters. So once you know the parameter, you can use it in real life application. So to find out these parameters, one need a data set. So that data set is nothing but input and output. So where input is x and output is y. So these form two vectors and each one has n components. So one can say data is an n-dimensional data set. Now here, consider example of this straight line equation model, which is shown by the red line, while the data set is indicated by blue color dots. Now one has to estimate w's in such a manner so that it will approximate this data set shown by the blue color dots with a straight line, such that the average mean square error for all the points is minimum, and this is called optimization function, which is shown by summation of e square. Now here, since we are having n data points, if you substitute for x and y, you will get set of equations. Now in general theory of linear algebra or simultaneous equation, since there are two unknowns, two equations are sufficient to find the values of w0 and w1. However, since there are n data points are given, we are coming across n equations. Since number of equations are more than number of variables, you will get infinite solutions in this model. Now, how one can find out a best solution out of this infinite solution, and therefore one has to study another subject which is called optimization theory. So this is one of the requirement of a subject in artificial intelligence. Now these equations can be expressed in a matrix form as y is equal to x into w. Right now, don't worry about linear algebra theory. Here, just try to understand the concept, how one can solve this equation. So by rearranging this equation and multiplying on the left hand side with x transpose, you'll get this new equation, x transpose into x into w is equal to x transpose into y. Now x transpose into x is a square matrix, and inverse of the square matrix exists. So one can solve the equation for w using x transpose into x whole inverse multiplied by x transpose into y. So the matrix on the left hand side of the y is called pseudo inverse, and the technique is called least square method. Right now, this matrix solution is not important. I'm just explaining this equation to give or to understand that one has to have a background in linear algebra as well, along with the optimization theory. So this lecture will also explore what are the various subjects required if one has to gain expertise in the area of artificial intelligence. Now this part of estimating W is called a training, and the algorithms are involved called training algorithm. Now this is a very simple process, as I explained. In real life scenario, the number of parameters are couple of thousands to millions of parameters, and the process is not so straightforward to implement as a pseudo inverse or least square method. And there are so many other aspects are also involved, non-linear models, linear models. So it needs a different technique to estimate W's. But right now, the concept involved is a training of algorithm, which is nothing but estimating weights of your model. Now, once you find out the weight, assuming we know the algorithm to estimate the weight and achieve the required accuracy in the model or a desired mean square error, one can deploy this model in real life application, which is called inference process. So there are two steps involved in artificial intelligence designing of deep learning model. The step one is training, and the step two is inference. Training will estimate the parameters of the model W, and once you achieve desired accuracy or error, it can be deployed in real life application, and the process is called inference. Here there is one important point. The training process is not that straightforward, because in first time you may not get a desired accuracy or error, and therefore it is an iterative process, which we'll see in detail in the next lecture. Now we'll see the overall flow diagram of AI modeling, training and deployment. So just now we saw what is an AI model. Basically, y is equal to f of x comma w. It is a sum function. The model is nothing but sum function in terms of x and w. Typically, this model does dot product plus bias plus nonlinearity, which is called a neural network model. There are some additional features are also involved in advanced model, like feature extraction, which is called convolutional neural network. Right now, don't worry about this. So we'll focus only on the mathematical model y is equal to f of x comma w, and then we are going to train this model so that we can estimate the values of w. The training is an iterative process, as I had mentioned. Typical algorithm used is called stochastic gradient descent algorithm, but there are other flavors as well. So right now, algorithm is not important. The important part is a training of the model to estimate the weights W. Now, in order to train the model, one need data set. And data set is a sample values of inputs and outputs. Now, how do you generate the data set? Now, these data sets in real life scenarios come from various sensors like camera, LiDAR, radar, sonar. These samples can be audio, speech. In medical imaging, it can be X-rays, MRI, computer tomography. So one has to learn another subject, which is called sensor technology, and how do they generate the data which can be processed suitable for generating the data set in the training of artificial intelligence model. Now here, once you have the data set in your hand, you can define training inputs and output. And the output is subtracted from the original output, which will give the error E. And then one can compute the mean square error. And that error is used in the training algorithm to update the weights of the artificial intelligence model. Now, how one can update the model? You can see the algorithm here, which is called Wiedrohoff LMS algorithm, which basically gives a mathematical foundation for incrementing weights W in the next iteration, which is called Wn plus 1, based on the previous value Wn minus the mu, which is called learning parameter, multiplied by derivative of mean square error. Now we'll see this algorithm in detail in our next lecture. Right now, the point is here, what algorithm is used in the training process. So here we have to focus on the training of deep learning model using some algorithm, and that algorithm is called stochastic gradient descent algorithm, which is a basic algorithm used in training of the deep learning model. So it forms here a feedback loop. So it forms basically a closed loop system. So every sample, the model will compute output Y, which is called predicted output, subtracted from original output, which will generate error E. And that error E is fed back to training algorithm, and the process will continue for multiple times. Now, how many times? It is again an open problem, and there are a lot of complications involved, which we'll see in our next lecture in detail. Now, this process is iterative, and that's why it is shown by these orange color arrows. What does it mean? Suppose if you don't achieve the required accuracy or error below a certain threshold, then the process, one has to repeat it by modifying the model, modifying the data set, and these are again open problem. So here I wanted to highlight a point. The training is not a straightforward process in artificial intelligence. Though the ready-made training algorithms are available in the framework, one has to have a background of various training algorithms to optimize your model so that you can achieve desired accuracy or error below certain threshold. Now, making an assumption, we have trained the model, and the model is such that it is giving you the desired accuracy. So you can take this model and deploy in real life application, which is called inference process. Now, how one can implement this model? So you'll need various hardware platforms, which are nothing but GPU platform, DSP platform, or system on chip platform. Sometimes people use hardware accelerator and then develop the software on this. Now, why these hardware platforms are important? Because real life models has parameters in the range of several millions, and it needs or it demands huge computational power. And therefore, choosing the hardware is not a simple job, because in order to make it real time, the hardware platform should have a required computing capability. Now here, in this lecture, we saw the various aspects of artificial intelligence and various subjects involved. So basically, AI is a collection of various subjects, right from sensor technology, signal processing subjects like speech processing, audio processing, image processing, video processing, training algorithms which involved Wiedrohoff LMS algorithm, which is a subject of adaptive signal processing, and then various framework. So in this lecture series, we are going to focus on each aspect right up to implementation of these models using a suitable framework like TensorFlow, which will offer you the hands-on experience in implementing deep learning models and their deployment in real-life application. But try to understand the point here. There are multiple steps involved if one has to gain expertise in the area of artificial intelligence. The first part is architecture of the model. The second part is generating the data set coming from various sensors. The third part is training of the algorithm and estimating various cost functions such as error or accuracy so that you can achieve the desired goal. The fourth part is inference operation on given hardware. And another important aspect is fitting this entire flow diagram into a given framework like a TensorFlow, which will give you the model, then optimization of the model, and then deployment of the model on suitable hardware. So I hope you must have enjoyed this introductory lecture on artificial intelligence, and thank you for your patience and watching my show.